The Federal Highway Administration's Mobile Asphalt Technology Center, or MATC, brings hands-on education, technology demonstrations, field pavement evaluations, and asphalt materials and mixture testing straight to the asphalt pavement community. The MATC introduces emerging asphalt technologies into practice, assisting agencies with positive change and promoting innovation within the asphalt industry. There are tools available that have been used in other industries successfully and now have applications in asphalt, specifically the X-Ray Fluorescence Spectroscopy. This technology can help to fingerprint key indicators of asphalt binder composition for use in quality control. The X-Ray Fluorescence Spectroscopy, or XRF, utilizes X-ray radiation to excite atoms within a sample, causing them to emit secondary X-rays, which reveal the elemental composition of the material. The XRF is a promising tool for accurately understanding the composition of paving materials, ensuring that they meet specific performance standards and contain the appropriate additives for enhanced durability and safety. The handheld XRF spectrometer measures the elemental composition of a broad range of materials. Using the handheld XRF spectrometer is straightforward and efficient, but first the sample must be prepared before testing can be performed. To prepare an XRF sample cup, begin by selecting the appropriate sample cup size for the analysis. Place a clean support film over the bottom opening of the cup, ensuring it's taut and free of wrinkles to avoid interference with the XRF readings. Secure the film in place by snapping the retainer ring onto the cup, ensuring a snug fit. Then, fill the cup with the prepared sample material, typically a fine powder or liquid, avoiding overfilling. Once filled, place another layer of film on top to seal the cup and snap on the top retainer ring. The cup is now ready for analysis, providing a contamination-free environment and allowing for accurate element detection during XRF testing. The technician begins by positioning the device directly over a sample of material, such as liquid asphalt in a small tin. Once the sample of material is centered under the XRF spectrometer, the operator pulls the trigger to initiate the analysis. It is important that the XRF is pointed directly at the sample material and no part of a technician's body comes in between the XRF and the sample material once the trigger is activated. The handheld XRF is traditionally more accurate with heavier elements, but can also operate in helium to enhance the detection of lighter elements. The results are displayed as a detailed spectrum on the device's screen, showing the presence and concentration of various elements within the sample. For example, when searching for signs of elevated levels of recycled engine oil bottoms, REOB, the elements of interest include calcium, zinc, molybdenum, and copper. If higher concentrations of these elements are detected, a closer look should be taken to check for contamination of the binder. This elemental breakdown is crucial for assessing the material's composition. This quick and accurate analysis method is invaluable for field applications. It allows technicians to verify that the materials meet the necessary specifications and standards, ensuring the quality and safety of the paving materials being used. Additionally, the handheld XRF spectrometer is essential for identifying contaminants that might affect the performance of the asphalt. By detecting unwanted elements, technicians can take corrective actions before the materials are used in construction, preventing potential issues with asphalt mixture performance once the final pavement is placed and in service. The portability and ease of use of the handheld XRF spectrometer make it a versatile tool for both laboratory and field environments, enhancing the efficiency and reliability of material testing in various settings. However, it is important to follow safety guidelines. Do not point the device at another person. Avoid dropping the device, and always transport it securely in a case to ensure safe and effective operation. Combining the XRF with other technologies allows technicians to comprehensively assess both the chemical and elemental makeup of paving materials, ensuring quality and safety in asphalt production and maintenance. To learn more about the XRF and other testing activities being demonstrated by the MATC, visit our website at fhwa.dot.gov/MATC.
Learn more at www.fhwa.dot.gov. Follow the Federal Highway Administration on Facebook, Instagram, Flickr, LinkedIn, Twitter, and YouTube. The U.S. government does not endorse products or manufacturers. Trademarks or manufacturers' names appear in this video because they are considered essential to the objective of the video. They are included for informational purposes only and are not intended to reflect a preference, approval, or endorsement of any one product or entity. Except for any statutes and regulations cited, the contents of this video do not have the force and effect of law and are not meant to bind the public in any way. This video is intended only to provide information to the public regarding existing requirements under the law or agency's policies.